Hello everyone. Today we will revise all the differentiation formulas starting with d by dx of x to the power n is equal to n into x to the power n minus 1. So for example, if we are taking d by dx of x square, so as per the formula here in place of n we are having 2. So the value becomes 2x to the power 2 minus 1, which is 2x. Okay. So if I take d by dx of, let us say, x raised to 5, again in place of n, now we are having 5. So this becomes 5x to the power 5 minus 1, which is 5x raised to 4. So one more example we'll take with the fraction as a power. So if I take 5 by 2, so its derivative becomes, now again comparing with this formula, here n is 5 by 2. So what we are going to write, n into x to the power n minus 1, which is 5 by 2 into x to the power 5 by 2 minus 1, which gives, after simplification, x to the power, here 2 is the LCM, 5 minus 2 is 3 by 2. So in this way we can use this basic definition of differentiation. Now if the function is x raised to n, and if we are differentiating with respect to x, directly we can say n into x to the power n minus 1. But instead of x, if we are having function of x, which I am saying it as f of x to the power n, so the formula becomes n into f of x to the power n minus 1. So the formula would be same. In place of x we are having f of x, but additionally again we have to differentiate this f of x with respect to x. So n into f of x to the power n minus 1 into f dash x will be the formula. So any function of x, let us say I am taking x square plus 3x to the power 4 whole to the power 5. Now I will compare. Here f of x is this function x square plus 3x raised to 4, and the value of n is here 5. So what the formula would be, here n into n is 5, f of x, so as it is the function f of x, we are writing here x square plus 3x raised to 4 to the power 5 minus 1, because n is 5, so 5 minus 1 is 4, into f dash of x, so into derivative of this function, that is f of x. Its derivative is, derivative of x square is 2x as per the above formula, first formula, 2 into x raised to 2 minus 1, plus derivative of 3x raised to 4, 3 is constant, x to the power 4, its formula is 4x to the power 4 minus 1. So this is f dash of x. So just we'll simplify this. So 5x square plus 3x raised to 4 to the power 4, 2x plus 3 into 4, 12, x to the power 4 minus 1 is 3. So the formula would be like this. If it is not x, if it is the function of f of x, so we will use this formula. Okay. The third formula is derivative of a constant function, so it is always 0. So if I am taking d by dx of, let us say, a constant k, its derivative will be 0. So fourth one, derivative of root x is 1 upon 2 root x. Okay. What we have to remember, root x becomes 1 upon 2 root x, and if I take root f of x, so any function of x instead of exactly x, now if we are taking any function of x, it becomes 1 upon 2 root f of x, again derivative of f of x is f dash of x. So here if I take d by dx of root, in place of f of x I am taking it as x square plus 2, which is a function of x. So as per the formula, that becomes 2 root, in place of f of x again I am substituting x square plus 2. Now the derivative of this f of x we have to write here. Okay. So the derivative of f of x is, derivative of x square is 2x, and derivative of 2 will be 0, because there 2 is a constant. So in place of f dash of x, here we are getting 2x, which is the derivative of this function x square plus 2. So next function is d by dx of 1 by x. So d by dx of 1 by x is minus 1 upon x square, or we can write it as x raised to minus x raised to minus 2. So how we are calculating this? D by dx of, I can write it as x raised to minus 1. Again using the same formula, that is d by dx of x raised to n is n into x raised to n minus 1. Using the same formula, here the value of n is minus 1. So minus 1 into x raised to minus 1, again minus 1, this minus 1, which gives minus x to the power minus 2. That I can write minus as it is, and x to the power minus 2, if I shift to the denominator, it becomes 1 by x square. So again we are using the same formula, but it would be easy if we remember the derivative of 1 by x as minus 1 by x square. Okay? So again the derivative of, instead of 1 by x, if I am taking 1 by f of x, so always we will not get as if in the form of x. So most of the times we supposed to find the derivative of a function of x, which we are denoting it as f of x. So we have to use the formula in this way. So minus 1 upon f of x square into f dash of x. So formula would be same, minus, instead of minus 1 upon x square, we are having minus 1 upon f of x square, but again we need to take the derivative of this function as f dash of x. Okay? For example, d by dx of 1 upon 3x plus 2. So this is f of x. So how can we write? Minus 1 upon 3x plus 2 whole square. Again derivative of this 3x plus 2 is, derivative of 3x is 3 and derivative of 2 is 0. So in this way we will apply the formulas. Moving towards the next one. D by dx of sin x, now the trigonometric function, d by dx, so that is derivative of sin x is cos x. Derivative of sin x is cos x. And if I am taking derivative of sin f of x is cos f of x into f dash of x. For example, d by dx of, that is derivative of sin x cube. So here f of x I am taking as x cube. So its derivative becomes cos x cube, and again derivative of this x cube becomes 3x square. So in its first formula we are using, the general formula we are using here, derivative of x cube is 3x square. Similarly, derivative of cos x is minus sin x. So what we have to remember, derivative of cos x is minus sin x, and in place of x, if I am taking cos f of x, the derivative becomes minus sin f of x into f dash of x. So d by dx of cos f of x, if I am taking as e raised to x, so derivative of cos e to the power x is minus sin e to the power x, and again derivative of e to the power x is e to the power x. Okay. Ninth, so here always, so I will add here derivative of e to the power x is e to the power x. Okay. You can remember. So we will go in detail about this also. So if I take, so I'll take an example here only, e to the power x square, let us say. So e to the power x square becomes e to the power x square. Again derivative of x square is 2x. So here we are using the formula d by dx of e to the power f of x is equal to e to the power f of x into f dash of x. So, and this formula only we are applying here. Derivative of e to the power x is e to the power x. This formula. Next is derivative of tan x is sec square x, then derivative of tan f of x is sec square f of x into f dash of x. So that is, if I take f of x as root x, and we know the derivative of root x is, that is derivative of tan f of x is sec square f of x, means sec square root x, and again derivative of root x is 1 upon 2 root x. Next formula, derivative of cot x is minus cosec square x. Similarly, derivative of cot f of x is minus cosec square f of x into f dash of x. So in this way we can find out the derivatives of trigonometric function which are with not only with x, which are the functions of x as f of x. So moving ahead, derivative of cosec x is minus cosec x cot x, and derivative of cosec f of x is minus cosec f of x into cot f of x into f dash of x. Okay. So one more trigonometric function we have, d by dx of sec x is sec x tan x, and if I consider instead of x, if I consider f of x, so d by dx of sec f of x becomes sec f of x tan f of x into f dash of x. Okay. So for example, I will add one more example to this. If I am taking sec 1 by x, so f of x I am taking here as 1 by x. Okay. So the derivative becomes sec 1 by x into tan 1 by x. Now again derivative of 1 by x is minus 1 by x square. This we have seen this formula earlier. Okay. Next is d by dx of sin inverse x is 1 upon under root. These are the just we are revising these formulas which will be useful for most of the examples which we are going to solve. Okay. Most of the times we use these formulas instead of x, we will use these formulas with f of x as a function of x. So d by dx of cos inverse x is minus 1 upon under root 1 minus x square. Similarly, d by dx of tan inverse x is 1 upon 1 plus x square. Then d by dx of log x is 1 upon x. So here if I take instead of x log f of x, so it becomes 1 upon f of x into f dash of x. So we can more particularly, in place of f of x, if I am taking x square plus 2. So in place of f of x, it is x square plus 2. What I can write? 1 upon f of x, that becomes x square plus 2. Now derivative of this x square plus 2. So derivative of x square is 2x and derivative of 2 would be 0. So in this way we can use this formula here. So these are the derivatives, basic formulas, rules of the derivative. One more formula I will add here. D by dx of a to the power x is a to the power x log x. So here what log a. So d by dx of a to the power x is a to the power x log a. So if I take a to the power f of x, so here base is constant. What you have to remember in this formula is base is constant and power is function of x. Okay. So the formula become a to the power f of x and log of base, that is a, into f dash of x. So we will use these formulas further in next videos to solve the partial derivatives. Okay. Thank you.